everyone. In this video I'm going to show you how to trace more complex numerical recursive functions, and I'm going to do that visually and also with the debugger within Eclipse. So here I've got a recursive method called sum of even digits, which does exactly what the name suggests, and what I'm going to do is I'm going to trace this recursive call starting from here. So we know that when we run our program, the first thing that we run is main. So to start with, we've got main on our call stack. So that's the scope that we're in. And inside main, we're on line 3. We say integer n is equal to 18672. And then we've got total even on line 4, which is equal to the output or the return of sum of even digits n. So we're at this point here on line 4, total even is equal to the output of this function. So that means that we jump out of the main scope and into the scope of this function here. And this method is put on top of the call stack because that's the context that we're in currently. So once we enter this function here, so we're on line 9 now, we're checking, we've got val as our parameter. So I'll just write that above here. This is our parameter value. If val is equal to 0, so it's not, and we skip that, we've got last digit is equal to val mod 10, which is 2 because we're taking the last digit. We've got remaining is equal to val divided by 10, which is 1867 because we're chopping off that last digit. And then on line 14 it says I've got a variable called subresult, which is equal to the output or the return of this function call. So I've got a different function call, sum of 1867, which means that I am jumping into a new function that method is put on top of the call stack. That's the scope we're in now. So we're leaving this scope here, we're jumping into a new scope, and then we'll continue on with this here once we know what the value or the return is of sum 1867, but we don't know yet, so we have to keep on recursing until we get to our base case, until we get to a value. So now we're in the scope of sum 1867, so we start all over again. So now we're on line 9, we're checking is val equal to 0, no. We get our last digit by doing mod 10, 7, we get the remaining by dividing by 10, 186. And then again, subresult is equal to the output of this function. So now we need to work out what that output is. So we jump into that function and we keep recursing. So again, is val equal to 0? No. So we'll go to line 12. We get the last digit, mod 10. We get the remaining, divided by 10, we get 18. And again, subresult is equal to sum 18 this time. So we need to work out what that returns. So this gets put on top of the call stack. And now we are back on line 9. So if val is equal to 0, so it's not, so skip over that. We've got last digit is equal to val mod 10, which is 8. We've got the remaining as 1. And then subresult is again equal to the output of this recursive function call. So we're recursing again. So now we're back into this function. Is val equal to 0? No. We've got last digit is equal to val mod 10. We've got remaining is equal to val divided by 10, so we get 0. And now I've got subresult is equal to sum 0. So what does sum 0 return? So now we're finally in this scope here where we get to sum 0, so val is equal to 0. And on line 9 it says if val is equal to 0, we return 0. So finally we're at a point where we're returning a value. And we know that when we return a value, we're exiting that function and we're returning to the previous scope. So that means that we're popping that off our call stack and we're returning it back to the function call. So sum 0 was called up here. So the return value of 0 is being returned to that there. And we're popping that off the stack. So we're exiting that function. And if we get to sum, well, now we're in the context of sum 1, and I wrote down that the last number that I was on was line 14. So I'm on line 14, so I need to continue on where I was at in that function. So I was at line 14, now I have the value of subresult, so I can continue on with my function. And now I've got a variable called result. And I've got a condition that says if the last digit is divisible by 2, or modulo 2 is equal to 0, it's not, it's 1, so we go to else, result is equal to subresult. And then I'm returning result, which is 0. So again, this return value is being returned back to the function call, which is up here in a different function scope. So we'll return it back up to where it was called. So that is 0. And then we can take this off our stack because we've left that function. And again, we'll just continue on with this. So we've got result, is last digit divisible by 2? Yes. So what are we doing? Result is equal to last digit plus subresult. So result is equal to 8 plus 0, which is just 8. And then line 22 says we're returning result, so we're returning 8. And again, we're returning that to the function call up here. We've exited that function, now we're back up here, we can continue from line 14, which is what we were up to. We've got a variable called result. We've got our condition that says, is last digit divisible by 2? Yes. So result is equal to last digit plus subresult, which is 14. Line 22 says we're returning result, which is 14. So we're returning that back to the function call. And then we're exiting this function. So one by one, we're going to keep moving back towards our main function, taking these methods off our stack until we can get our final result. So is last digit divisible by 2? No. So result is subresult, and then we're returning result. And that is being returned to the function call up here. Now we're close. So we've got result. Is last digit divisible by 2? Yes. So we've got last digit plus subresult. So we get 16. And we know we're returning result, which is 16. We're returning that back to the function call. So now we're returning this back to our main method. We've made our way back there. We've exited this function, so we can pop that off the stack. And now we can continue on from where we left off in the main method, which was line 4. And the only thing left to do is line 5, which says print out the value of total even, so you should get 16. So that's how you would trace that visually. I'll just jump over to the Eclipse Debugger to show you how it works there. So using the debug, you can create some breakpoints. So I'm just going to create one breakpoint at this function call here. Now I'm going to step through my code. So to toggle a breakpoint, you can use, or if you're on a Mac, you can use this shortcut here, or you can just right click and go toggle breakpoint. And then to run it in debug mode, you're going to click on this button here, or if you go run debug. When you do that, you'll get the debug perspective where you can keep track of your variables and you can keep track of your stack as well. So we know that initially we're in the main method up until this point here. So we've run all this code. So we've created this variable here and that's being tracked here. So I've stopped my code here because I want to see what happens when I run this line of code. And we know that when we run this code here, we'll jump from our main method into the scope of some even digits, n, 18,672. So what should happen here after I step into this code, so we want to step into, not step over. Once we step into our code, we should have the function appear on the stack. And we should also have some new variables here, including val, which will be the value of n. So if I go step into, so what's happened is I was in the main scope, and now I'm in some even digits on line 11. I've got vals here. So if I keep stepping through my code, I can see is val equal to 0? No. So jump over that. I've got last digit, so once I run that, a new variable should appear here with the last digit, which is 2. The remaining should be 1867. Great. And now I've said subresult is equal to sum of even digits remaining, which is this value here. So now this should place this on top of the stack again, and we'll enter the new scope, which is this function here. So if I step into this, it'll be added on here, and we'll head back to line 10. Cool. So what's happened here, if we trace back through our stack, the last line I was on was line 6, and it's got all of my variables here as well, which is what we kept track of before. I've got what I'm up to in that previous scope here. So I was on line 16, which is helpful that it keeps track of that, and it keeps track of all my variables at that point. But now I'm in this scope, so I'm going to continue on. So now I've got last digit should be 7, remaining should be 186. And now I'm calling this function here, so I'm doing another recursive function call, so this should put that on the stack. Cool, so I can look back at the state of that function before I left it and jumped into the next scope. So all of that, those values are saved there. So we can keep on going through this. Last digit 6, remaining is 18. So that will add another one on top of the stack. Last digit is 8, remaining is 1. I've got another recursive function call. Remaining is 0 now. So now we've got all of these recursive function calls here, and I'm up to val is equal to 0. And we know when val is equal to 0 that we're returning 0. So what's happening here, after this condition here, I should jump to line 12, which says return 0. So that means I'm returning 0 back to the previous scope, because we know that when we return, we exit the function, which means this will be popped off the stack. We'll jump back to this function here, and we'll resume from whichever line we were up to, which was line 16. So the value 0 is being returned back to this here, to subresult. So if I go step into, you'll see that that will disappear. And now we're back into this previous scope. And now that we're in this scope, we can continue on with the rest of our code because we know what subresult is now. We know that it's equal to 0. So I step here, subresult is equal to 0. And just as we did when we were tracing visually, we can continue with this here. So is the last digit divisible by 2? No. So we head to our else, so line 22. Result is equal to subresult. So now result is equal to 0, and we're returning result. So that means that we're returning result to this previous call here, and we're returning it back to line 16, which is where we're up to. So now subresult in this scope should be equal to 0. So when I step here, should pop that off the stack. And now we're back. And again, we can continue on with the rest of our code because now we know that sub-result is equal to 0. So that will be updated here. So is the last digit divisible by 2? Yes. So we're going to go to line 19. Result is equal to last digit plus sub-result. So now result should be equal to 8. Cool. So we finished this if, which means we'll jump to line 24, and we're saying return result. So we're returning 8 to this one here, to line 16. So now this sub-result should be equal to 8. So I'll step back to line 16, and if I step again, sub-result's equal to 8. So we can keep going through these here. So the last digit was 6, which is divisible by 2. So result is equal to last digit plus sub-result. 6 plus 8, 14. We get to return result. So we're returning result to the previous function, which means we're taking that off the stack. So we're returning result, which is 14, because our last digit was 7, which was not divisible by 2. So taking that off the stack, and you continue on like that. And now we're back to our main method because we found out what that initial function call returned. When I finally run that, we're finished running our code. Oops, probably should have stepped over that one. And we're printing out 16, which is what we got.